to the same side. Generally speaking, you could move it to the left or the right. Why is it more common to see it all move to the left? What's already here?
The x cubed.
Yeah, keeping the leading term positive is usually a little helpful in factoring. What's your favorite leading coefficient? 1. So keep it 1. So then when you get to here, I did teach you potential rational zeros in the synthetic division, but you should always just check, can you do it with grouping? And in this case, does grouping work? Grouping does work. You can factor out the x squared, you can factor out the -1, and then you get difference. What is this? Difference of squares, that goes to there. So the -3, -1, and 1 are the 3 solutions. So right now, factoring cubics, you look, is it groupable? If not, you're going to have to, hey, does it give you a factor? No. List potential rational zeros and test them. They're going to have to do that at some time. Yes. It's just something you're going to have to do.
How do we do that again?
Once we gain, it tells us that -1 is a solution. If -1 is a solution, what does that mean as a factor? If you know that -1 is a solution, what's the factor that it means is present in the polynomial? X plus 1. The 0 makes the factor 0. The 0 makes the factor 0. So what do you plug -1 in to get 0? Well, x plus 1. So you take that -1 right here, and it goes right there. And what's that first step? You just drop the 6. And then how do you get from all these diagonals? What are you doing in each of those cases? You're multiplying by the -1. And then what are you doing between the -5 and the -6? Adding them. So you're adding between the two. Is that a nice thing to see? Why? Why is that a nice thing to see?
It means that there's only going to be 3.
Well, what does the number 0 tell you about the -1 here? It tells you...
That it is a solution.
Correct. It is a solution because it makes it 0. Yeah. You just verified what it told you, but the really awesome byproduct is right here. And you see how those terms are written out in reverse order, starting with the c, then the x, then the x squared, and then they go right to there. At this point, though, this is where you might have been a little bit consternated, right here. What do you have to still be able to do with this? Factor it. And if for some reason you get totally stuck on the factoring, if you got totally stuck on the factoring, what could you always do on this? What's your safety valve for quadratics? What could you use? The quadratic what? You could use the quadratic formula. On this one, is it nicely factorable? Yes. Is it straightforward? No, it's not straightforward, but as long as you test out the pairs. The challenge is that 6 could either be 1 and 6 or 3 and 2. So you have to test out a few of them. But once you test them out, you get all of these answers right there. I would say for me, honestly, that factoring that is the most challenging part for me, because this is just a lot of little steps, and as long as you do the little steps carefully, it should just fall out to be 0. You asked about this one because this one is a little different. Why is this one a little different than the ones we've looked at before? What's different about this one? It's missing a what? Cubic. So what can't you do on this one? What automatically you know you can't do? No what? What's the one tactic you had before yesterday for factoring higher degree polynomials? Grouping. So there's no grouping on this one. You really need all of the powers in order to do grouping. So this one is a little different. Has anybody seen things like this before where it's even powers like to the 4th and squared? Has anybody seen that before? I like my term for this. It's not something textbooks use, but I like calling this fake quadratics. I like calling them fake quadratics when you have a 4th power and a square. So this is why I like calling it fake quadratics. Going from this to this is a little challenging. I like to change it to this. Give me any letter you want. Pick a letter. G. I'm going to let G, capital G, be x squared. If I let capital G be x squared, can you rewrite the initial phrase for me right here? What is this going to be in terms of G? If G is equal to x squared, what is it going to be? G squared minus 100 equals 0. We now have a quadratic. Can you factor that for me? What two things multiply together to get 100 but add together to get -21?
4 and 25.
So it's going to be, what does this factor into? G what? G minus
Plus 4 or
minus 25 times G what?
plus 4
Equals?
0.
Oh, but what does G equal? So therefore, x squared minus 25, x squared plus 4 is equal to 0. And then this factors because what is that called? The difference of? So you have x plus 5 x minus, not 4, x minus 5, x squared plus 4 equals 0. Can someone tell me what the two real answers to this are? What are the two real solutions? Arvin. So you have plus or minus 5. Anybody want to tell me what the two imaginary solutions are? Plus or minus? Yeah.
X plus 2i times x minus 2i.
There can't be x in your answer. So x is equal to what number? Plus or minus?
Plus or minus 2i.
Ah, I see what you're saying. Plus or minus 2i, yeah. That would be the 4. So these I'm not expecting you to have. I would only expect you to have these right there. Yes?
So if you have like a third value that has like an x squared in it,
Yep.
should you just kind of not mess around with that?
Only if it's a plus, because the reason this is imaginary is because x squared plus 4 doesn't touch the x-axis. So asking where it crosses the x-axis results in an imaginary solution. But if it is, for example, let's say just I change this. Let's say it was x squared minus 3. Are there two real answers to that? You'd say x squared minus 3 is equal to 0. So x squared is equal to 3. So what does x equal? Plus or minus square root of 3. That is real. That's a real number. There's no I in it. So only if it's x squared plus a number. Only if it's x squared plus a number. You can't take a square root of negative and stay in the real numbers. You can do it. You just can't keep it in the real numbers. You can't keep it in the real numbers. That's right. Now, can someone tell me what the domain's going to be? X such that x can't be what?
3.
Can't be 3. Yep. Any holes?
No.
None. What's the one asymptote? Or two asymptotes, actually.
X equals 3, y equals 0.
Yep. Good job, Lindsay. That was Lindsay, right? Was it? Yeah. Thank you. End behavior. What happens as x goes to infinity and negative infinity? So the limit as x goes to infinity of f of x is what?
0.
And the limit as it's 0 from the top. Yep. X goes to infinity of f of x equals 0 from the negative. Sorry, I didn't switch it. Yep. Thank you. Yep. And what about x-intercepts? Did you find any x-intercepts?
No.
Why? Why can't there be any x-intercepts on this? How can you tell that from the fraction? There's no x on the top. It's just a number, so there's no way to make it 0. So there are none. And what about the y-intercept? That's 0, comma, negative 5/3. So when you put that all together, you end up with an asymptote at 3. And then you end up with a graph with 0, negative 5/3, like a 0, almost negative 2, so like right about here. It goes down, doesn't cross, and then does this. Yay. Good job. Looks good, everybody. X is x such that x
X is not equal
2. Yep. Noah, are there any holes?
No.
There are no holes. Natalie, can you tell me if there's a vertical asymptote?
Yeah, x equals 2.
So x equals 2. Is there a horizontal asymptote? Anybody know if there's a horizontal asymptote? Lindsay, is there a horizontal asymptote?
Oh yeah, y equals 1.
Why is it y equal 1?
Because x divided by x.
Perfect. Yes, because x divided by x, the leading terms is 1. Excellent. Very good. Okay, so what about end behaviors? You kind of answered that, right? So what's the limit as x goes to infinity of this function? As x gets infinitely big, what does this go to?
1.
You just figured out because it's 1. And then the other one, the limit as x goes to negative infinity of f of x is going to be 1. Now you could figure out the sidedness or wait until you graph a little more to figure out the sidedness, but they both go to 1 because we know the horizontal asymptote is 1. Yes, Al?
We're allowed to just do x goes to plus or minus infinity, right? Equals 1.
If it's the same, but it's not in this case because I want the sidedness. So what haven't we written in for these limits yet? We haven't written in what side you approach from. So if they approach from the same side, then yes, you could do plus or minus. But we need to do a little bit more work and then figure out what side you're approaching from. What about the x-intercept? What's the x value of the x-intercept? Anybody who has this? David, what do you got? X-intercept for the, where does
X equals -4,
comma,
0.
yeah. Are there any other intercepts? Nope. What about when y equals, so y-intercept, what's that going to be?
0, -2.
0, who said that? Yeah, good job. So what do? You can bring the whole room together now. So you have -4 for there, you have -2 for right there, and then you have an a horizontal asymptote right here. So what's this going to look like? It's going to go, oh, and is there a vertical asymptote? at x equals what? 2? Did I put that at the right place? That's too high, isn't it? Why is that too high? Where did I just put that? I put that at 2. I need to put it at 1, so it's down closer, like this. And then the other one is here. I like labeling, so that's x equals 2, and that's y equals 1. So what does this look like? It's going to go down, connect, and up, and like this. So now can we answer the sidedness of the end behavior? We can. So as it goes to infinity, is it coming from the top or bottom? And as it's going to negative infinity, is it top or bottom? Bottom. Exactly. Exactly, exactly, exactly. Good. We just drew a fancy line. So you ended up with a hole right there. It connects at 0, 4, and then what happens in between? It's just a what? It's just a line. It's just a line. 2x minus 4, and it happens to have a discontinuity. Can you make lines look really complicated? Sure. Let's say, so we just graphed what? We just graphed 2x minus 4, right? That's effectively what we graphed. Let's say we wanted a hole at, x at 2, 2. So we did this, right? That's effectively what you had there. This is the same thing as this, right? You could add in as many holes as you want. Let's say I wanted to add in a hole at x equals 3. What's the only thing I add in here?
X minus 3.
And exactly. So I could keep on adding things on here, right? If I did this as well, have I changed? Is it still a line? I've only added in what? Holes. I've added in a hole at 3, and I've added in a hole at 5. That's it. That's all I've done. So if that one is right there, this one is right there, and the only annoying thing really is that the first discontinuity, so this hole right here at 2, also happened to be on the what? X-axis. So it seems like a contradiction. Like, what's the x-intercept? 2, 0. Like, well, 2 isn't. Oh, that's because the hole happens to be on the x-intercept. Theoretically, could you generate a hole right here? What would I have to add into the top and the bottom to make a hole right there?
X plus 1.
No, it's a y. It's just, what's the x value? The x value is 0. So what do I plug in, like right here? What do I do? X and x. If I put an x and an x right there, it makes it so that 0 isn't in the domain, right? You could have a hole right there instead of an intercept. Now, this would just be more annoying for you because theoretically, you'd want me to give you the factored form, right?
Yeah.
Because if I multiply this out, you have 1, 2, it's a fourth, you don't really want to factor that. You can though, because you know how to find rational zeros now. But would you want to? Especially since all you're really doing is drawing a fancy what? A fancy what? A fancy line! Okay, by yourself, everybody. All by yourself. Try this one right here. All by yourself. What's the fully factored numerator? Can someone tell me the fully factored numerator? Who wants to volunteer? No, what's the fully factored numerator?
4 and then in parentheses,
Yep.
x minus 2 and x minus 1.
Nice. And someone do the fully factored denominator for me? Raise your hand. Someone knew. Yeah, Natalie.
3x plus 2x minus 2.
Nice. What's the domain? Someone new who hasn't spoken on this one yet? Go.
Polynomials, what? 2 and 1.
Negative 2 and what?
1.
Negative 2 and, look at the denominator. Look at the denominator. 2 and,
Oh, was it
yes. Are there any holes? Someone new for this problem. Someone new. Are there any holes? Anything cancel? Someone raise their hand. New. Chris.
the x minus 2?
Yeah, so what's the hole? X equals?
X equals 0.
No, x is going to be 2.
Oh, I mean, sorry, like y.
So if we plug 2 into there, what do you get when you plug 2 into what's left? After you cancel, if you plug in 2, what do you get, Alex? I think you get 1/3, don't you? So if you cancel these out, plug in 2 right there and right there, you get 4 over 12, which is 1/3. I agree, yeah. Nice. What about the end behavior on this? So that would be the horizontal asymptote. What would the end behavior on this? You could say the horizontal asymptote. What is the horizontal asymptote on this? Someone knew? Sorry, what did you say?
4/3.
Yeah, y equals 4/3. And what would you say? I like the limit as x goes to infinity of f of x is 4/3. And also what? The limit as x goes to negative infinity is? And what haven't we written in yet on this? We haven't need the sidedness. We'll do that at the end. What about the x-intercept? You look at the factor, you look at the fully simplified. What's the one x-intercept? Lindsay, what's the x-intercept on this one?
1 plus 0.
Yeah, because when you plug 1 into the numerator onto the simplified, you get 0. You put this all together. Do we have, it didn't ask you for vertical asymptotes, but where is the vertical asymptote? There's one vertical asymptote. Where is it? -2. Oh, it did ask for asymptotes. Thank you. So yeah, so it's going to be y equals 4/3 and x equals -2. Thank you. So the asymptotes, you have this one right here, and then where's y equals 4/3? 4/3 is like 1 1/3, so like right here. Oh, that's 2. Thank you. Thank you. That's too high, isn't it? So I'll use a thinner one for this. 4/3, so what is that, like right about here? Thank you. What's the, oh, and we didn't get the Y-intercept. Can someone tell me the Y-intercept? I didn't ask for it.
0 to -2/3.
Do people agree with that?
Yeah.
Okay. So we plug those in, 0, -2/3, 1, 0. So what's this thing going to look like? Oh, and do we have a whole 2 and what? 1/3, like that? Do people agree with what I'm doing here? Nice. So can you do the sidedness of the end behaviors now? Going to infinity, is it, what is it? From the bottom, so it's minus, and going to negative infinity. Oh, I did the wrong side there. So this one's going to be plus, and going to positive infinity, it's coming from the bottom. So you can wait on the end behavior there. You can wait on the end behavior.